So you take a paper plate, you take a paper plate. This is the paper plate. You attach a stick. This is the stick. This is the paper plate. Now you place chart paper, folded one and make a hole and place the folded sheet. So this is the folded sheet. Now try the paper covered with the folded, lift it, she's lifting it up and how much effort is needed. Now place the second unfolded. This is the unfolded. So this is unfolded. Now if this unfolded, this has more area. The area is more. This has less area. This has less area. So now if the less area is there, lift the paper again and feel the effort. In which case is the with the he says you would observe that the more effort is needed to lift the which is covered with the unfolded. More effort here. More effort. More force. More force she has to apply. More force. Girl has to apply more force. Here less force. Less force. Now when she is lifting this up, she is actually lifting the weight of the stick, the weight of the stick, the sheet, and the paper plate. But if that was the only case, then she would have felt the same effort because she's also lifting the stick, the sheet, and the paper plate here, same paper, same sheet, but is unfolded. But what happens is there it is much more effort. Why? Because of air pressure. Now, notice that the weight has not changed. So the weight is same. So we can infer from this observation that air exerts force, which makes it difficult to lift the paper. Moreover, this force increases with increase in area. This means that air is exerting a force which increases as the area increases. A force per unit is pressure. So this is called atmospheric pressure, air around us. So basically, air exerts pressure on us. So why pressure? Air molecules are coming and hitting and going. Air molecules are coming and hitting and going. So like we did in particle chapter of particle nature of matter. In air, there are particles which are moving around and hitting. So they are hitting here, and because there's more area, they can hit more. So there's more force. Now, if there is force on this, if a girl standing here is blowing a balloon, there's air pressure outside. So she is pushing, creating air pressure inside. That is why when this air pressure is more than the outside, it will start expanding. So we can say that, and also because it expands in all direction, air exerts pressure in all direction. The balloon is expanding, and this air pressure can also be felt by a sucker. This is the thing which sticks to the wall when you hit it with a gun. And why it sticks is because when you press this, like generally it is this shape. There is air here also, there is air also. So air particles are hitting from this side, air particles hitting from this side. So it is not but if you press it, then it gives this shape. There is no air here because there is wall here or a table. So air is only coming and hitting outside. So when there is no, then it's very difficult to pull it out. So the sucker sticks to the surface because the pressure of air surrounding is higher than the pressure exerted inside the sucker. There is no air inside the sucker. To pull the sucker off the surface must be strong enough. So how much this you have to apply? You have to apply great force. So because on a 15 by 15 centimeter, nearly the weight of 225 kg. 225 kg means two people. Two people. So it's so strong. So that's why when you have to pull it, you generally slide it. You don't pull it. It's very difficult to pull it. Now there is so much of force acting, but why don't we feel it? You see, inside our body, we have got air goes inside our body also. That's why inside our body also we are experiencing. So that's why we don't feel that. But when you go to Mars, astronauts wear a suit because there is, or moon, because there is no air pressure. The pressure inside our body is high. So it's very dangerous to go without a suit. All the fluids, all the fluid inside blood is creating pressure. That pressure is equal to atmospheric pressure. If you go on moon where there's no atmosphere, this pressure will push out the liquid from your nose will bleed, you will die. So that's why they have those suits around them. But on the earth, you will not feel this air pressure because your air is also inside your body, in your lungs, and also the fluid blood pressure is balancing the outside air pressure. So this is all about air pressure.